Exercise 8L, question number 11. Y is equal to m sine of m sine inverse x. Okay, so derivative this dy by dx. Sine derivative is cos of m sine inverse x into d by dx of m sine inverse x. Okay, I'm comparing this with sin x formula. This entire thing with sin x formula. So x is nothing but m sine inverse x. So dy dx of m sine inverse x. Okay, chain rule. Now m will go outside. Derivative of sine inverse x is 1 upon root 1 minus x square. Okay, now like the previous sessions, this particular term I will shift it on the left hand side. So root of 1 minus x square dy by dx is equal to m cos of m sine inverse x. Okay, squaring both the sides, because if you take a look at the proof, in the proof left hand side we require this term. Okay, so we don't require a root over here. So after squaring, what we will get is 1 minus x square dy by dx the whole square is equal to m square cos square m sine inverse x. Okay, now look at this term. Cos square is 1 minus sine square. Why we do that is you'll come to know. Cos square is 1 minus sine square m sine inverse x. Okay, now the value of sine of m sine inverse x. Just look at the given statement. Sine of m sine inverse x is y. Okay, so sine square m sine inverse x. This particular value will be y square. Okay, so 1 minus x square dy by dx the whole square is equal to m square 1 minus y square. Open the bracket on the left hand side, on the right hand side, sorry. So this is m square minus m square y square. Okay, now derivate this once again. Left hand side, I'm going to apply u into v rule. Right hand side, m square will be 0, single constant. M square y square will derive. Okay, so v, that is dy by dx the whole square, derivative of u plus 1 minus x square, derivative of dy by dx the whole square. I did product rule, u into v rule. 0 minus m square being a constant will go outside. Derivative of y square. Derivative of y square is nothing but 2y. I'm comparing this with x raised to n. So 2y. If you compare this way, x is getting replaced with y. So dy by dx of y. Okay. So dy by dx the whole square. Derivative of 1 minus x square is minus 2x. Dy by dx the whole square. Derivative of 1 minus x square is minus 2x plus 1 minus x square. Okay. Derivative of dy by dx the whole square. This is x raised to n. So it is 2 dy by dx. 2 dy by dx into dy by dx of dy by dx. This is the chain rule part. Okay. If we compare this with x raised to n. Okay. So x is dy by dx and n is 2. So derivative of dy by dx. That is the chain rule part. And this will be left hand side will be right hand side will be minus 2m square y dy by dx. Minus 2 right hand side will be minus 2 m square y dy by dx. Okay. Now, if you take a look at the left hand side, 2 and dy by dx is common. 2 and dy by dx. So we'll take 2 dy by dx common. Within the bracket, I'll just write minus x dy by dx. The x is left, minus is left, so minus x. And dy by dx, one term is left. One has gone outside. Plus 1 minus x square. Okay. D by dx of dy by dx is d square y by dx square. Okay. The right hand side also, I'll just write it in this way. 2 dy by dx and into minus m square y. Right. So 2 dy by dx, 2 dy by dx is getting cancelled on both the sides. Okay. So I'll write this term first. 1 minus x square dy by dx. Okay. 1 minus x square dy by dx plus sorry minus x dy by dx minus x this is square. Okay, sorry, this is the second order derivative. 1 minus x square d square y by dx square minus x dy by dx plus m square y. What I'm doing is I'm taking this right hand side term on the left hand side. Okay, and right hand side will be 0. So don't you feel this is what is required in the problem as proof? Any doubts? Yes or no? Let's start with the next problem. Okay. Yes. This is the previous slide. If you're having any doubts, you can please ask. Okay, I'll just explain few things. Yeah. Is there any doubt on this particular page? This is u into v derivative of u plus u derivative of v. Okay. And right hand side minus m square 2y dy by dx. Here I've applied chain rule. Okay. Now after this is written as minus 2x in the next step. It's minus 2x, right? And this is x raised to n. So n into x raised to n minus 1. So x is dy by dx. So we'll derive dy by dx. Okay. Now here don't consider this as multiplication. This is not multiplication. So dy dx of dy by dx is nothing but d square y upon dx square. It is a second order derivative of the first order. Is your doubt clear? Which is this? Okay, fine. Yeah. And at the same time, I have taken y dy by dx, sorry, 2 dy by dx common from both the terms in the left hand side, and then I cancelled out both the terms. Fine. And then I've shifted this term, which is on the right hand side, to the left hand side. And that's how I get my final statement over here. Okay. So I'll start with the next problem right now. Question number 11. Earlier we were solving question number 10. Sorry, this was question number 11. We'll go to question number 12. Okay. Y is equal to a plus bx e raised to minus 3x. What do we need to prove? We need to prove that y double dash plus 6y dash plus 9y plus 2 equal to 2. So ideally this 2 and 2 will get cancelled. So eventually what we are supposed to prove? Y double dash plus y dash. Instead of writing y double dash, I'll just write d square y by dx square. That's the second order derivative. Plus 6 dy by dx plus 9y equal to 0. Plus 9y equal to 0. Okay. Yeah. Now see, first order derivative d by dx on both the sides. Right hand side, this is u and this is v. Right? So dy by dx, v derivative of u plus u derivative of v. I've done product rule, left hand side. A and B are constants that we all know. What is the derivative of a plus bx? The derivative of a plus bx is b. Correct. 0 plus b into 1. And the derivative of e raised to minus 3x is e raised to minus 3x d by dx of minus 3x. Chain rule. So I'll take you to the next slide. Dy by dx a plus bx into b plus a plus bx. Sorry, I just copied something wrong over here. Let me go back. E raised to minus 3x into b plus a plus bx into e raised to minus 3x d by dx of minus 3x by dx of minus 3x. So dy by dx is equal to e raised to minus 3x into b plus a plus bx. Acha, now see, at the same time, if you refer this clearly, a plus bx into e raised to minus 3x. What is this a plus bx into e raised to minus 3x? This value. It's y, correct, very good. Okay, into dy dx of minus 3x is minus 3. Fine. So dy by dx is equal to e raised to minus 3x into b minus 3y. Fine. So I'll take this minus 3y on the left hand side. I'll make it plus 3y. So dy by dx plus 3y equal to b e raised to minus 3x. Dy by dx plus 3y b e raised to minus 3x. I'm marking this equation number 1. You'll come to know why. Okay. Now we'll derivate this. We'll derivate this. Okay. What is the derivative of dy by dx? Is d square y by dx square plus derivative of 3y 3 divided dx dy by dx equal to b is a constant, it will remain outside. E raised to minus 3x is e raised to minus 3x d by dx of minus 3x. Okay. Yes. Now tell me, what is this value? B e raised to minus 3x. What is this value? We don't require it in the final proof statement. We don't require b and all. So what is b e raised to minus 3x? This value do we have? Yes. So that's the reason why I marked it equation number 1. So from 1, we'll get this value. So substitute that value, d square y by dx square plus 3 dy by dx equal to this value is dy by dx plus 3y into minus 3 into minus 3. So d square y by dx square plus 3 dy by dx, multiply this minus 3 with both the terms, minus 3 dy by dx minus 9y. Okay. Then send both the terms on the left hand side. Okay. Plus 3y dy by dx plus 3 dy by dx will be 6 dy by dx. Okay. Plus 9y. 9y also send it on the left hand side. Is this what is required? Have I completed my proof? Okay. Yeah. So that was question number 12. I will go ahead with question number 13 right now. Fine. Should I? Question number 13. X raised to m into y raised to n is equal to x plus y raised to n plus n. Okay. So too many terms with powers multiplication. So take log on both the sides. Log AB is log A plus log B, and right hand side log A raised to B, which is B log A. This is log a raised to b property b log a. Okay. Now n log x plus n log y is equal to m plus n log x plus y. Now we have to derive this because all log properties we have applied. Fine. M is a constant, so derivative of log x is 1 upon x. N is a constant, and so log y derivative is 1 upon y d by dx of y. M plus n is a constant, so log x plus y derivative is 1 upon x plus y d by dx of x plus y. So m into 1 upon x plus n into 1 upon y d by dx of y equal to m plus n 1 upon x plus y d by dx of x plus y. So m by x, n by y dy by dx is equal to m plus n x plus y d by dx of x plus y. D by dx of x is 1, d by dx of y is dy by dx. Put a bracket. So m by x, n by y dy by dx. Right hand side multiply this term with, put the terms in the bracket. M plus n upon x plus y into 1 is m plus n upon x plus y, and m plus n upon x plus y dy by dx into dy by dx will be this. So it is getting multiplied with both the terms. Now take dy by dx terms together, okay, and non dy by dx terms together. Okay, just copy till here. Then I will proceed with the next step. So n upon y dy by dx minus n plus n upon x plus y equal to m plus n upon x plus y minus n upon x. Okay, now group the terms. Take common on the left hand side. Dy by dx is common. N upon y, m plus n, x plus y, m plus n, x plus y minus m upon x. Now left hand side, right hand side, both the sides take LCM. Nx plus ny minus my minus ny. There is a minus sign in between, just remember that. Y into x plus y equal to mx plus nx minus mx minus my. Okay, x into x plus y. Now see guys, first of all x plus y will get cancelled. Okay, here ny will get cancelled. Here mx will get cancelled. So we are left with nx minus my. Here also nx minus my. So now we'll cross multiply. We are also left with y and x. So dy by dx equal to, first I will write down the right hand side, nx minus my upon x. Nx minus my upon x. Okay, now I'll write the, I'll just cross multiply now. This y will go on the right hand side. Y upon nx minus ny down, left, right hand side. Okay, this is getting cancelled. So dy by dx is equal to y upon x. So this is what we have got. But then we have to prove something else. Okay, so just refer the problem statement over there. What we have to prove? We have to prove d square y by dx square equal to 0. So derivate this one second. Okay, so left hand side will be d square y by dx square. Right hand side, apply quotient rule u upon v. So v derivative of u minus u derivative of v upon v square. Okay, so d square y upon dx square equal to x dy by dx. This becomes dy by dx minus y because this is 1 upon x square. Okay, now take a look at this part, dy by dx. What is the value of dy by dx? The value of dy by dx is y upon x. It's on the same page. Dy by dx is equal to y upon x. So this is x into y upon x minus y upon x square. So x is getting cancelled. Y minus y is 0. And 0 upon x square is 0. Right? Are you convinced with the solution of this particular proof? Okay. So let us go to question number 16. Let us go to question number 16. Okay. X is equal to t square, y is equal to t cube. X and y, they are functions of t. T is the parameter. Okay. So dy by dx is equal to dy by dt upon dx by dt. Do you remember this? Okay. So basically, x is equal to t square, y is equal to t cube. X and y, they are functions of t. Dy by dx is dy by dt upon dx by dt. Right? You know this? Do you remember this? Implicit functions? Sorry, parametric functions. T is the parameter. Okay. So we are supposed to find out first dy by dt. So what is y? Y is equal to t cube. So d by dt, differentiate with respect to t on both the sides. So dy by dt, we are differentiating with respect to t. So no question of changing. This is your dy by dt. Now x is equal to t square. D by dt of x, d by dt of t square. So dx by dt is equal to 2t. We got the value of dx by dt. Now put these values in equation number 1. Put these values in equation number 1. I'll show you equation number 1. See. So from 1, put the respective values. From 1, dy by dx is equal to 2t square upon 2t. Okay. So dy by dx 3 by 2t. Okay, so we got dy by dx, but then we require d square y by dx square. Okay, so differentiate this with respect to x once again. Okay, so d by dx of dy by dx, d by dx of dy by dx is d square y by dx square is equal to d by dx of 3 by 2t. Now be attentive over here. 3 by 2 will go outside, so this will be d by dx of t, right? So we have to find out this dt by dx. So this can be further written as 3 by 2 dt by dx. Now we have this value somewhere in the problem as calculated. So it's over here. If dx by dt is 2t, what is dt by dx then? If dx by dt is 2t, what is dt by dx? 1 upon 2t. Okay, reciprocal. So I'm going to replace this with 1 upon 2t. So square y upon dx square is equal to 3 by 2t into 1 upon 2. So 3 by 4t. Understood? I'll show you slide number 1. Parametric functions t is the parameter. Slide number 2. We are finding out dy by dt and dx by dt. Slide number 3. We'll put these values in equation number 1. Now once we get dy by dx, we have to derive it once again because we require d square y by dx square. So derive it once again. Left hand side will be d square y by dx square. Right hand side we have calculated c, and this is the final answer. Have you understood this or you are confused? Yes, let me know. Waiting for your feedback. Okay, let's go to 16 sub question 3. Sub question 2 you can do it for self study. X is equal to a cos theta, y is equal to a sin theta. X and y they are functions of theta. Theta is the parameter. So to find out dy by d square y by dx square, first we'll have to find dy by dx. So dy by dx is equal to dy by d theta upon dx by d theta. Theta is the parameter, equation number 1. Okay. Now start with y. Y is equal to a sin theta. We require dy by d theta. So differentiate with respect to theta on both the sides. So dy by d theta is equal to a cos theta. Okay. X is equal to a cos theta. We require dx by d theta. So differentiate with respect to theta on both the sides. So this will be minus a sin theta. Now where to put these values? We are supposed to put these values in equation number 1. Okay. So from equation number 1, I'll write from 1 dy by dx is equal to a cos theta upon minus a sin theta. So a is getting cancelled. So dy by dx is equal to minus cot theta. Dy by dx minus cot theta. Okay. Now this time we'll differentiate this with respect to x on both the sides. So dy dx of dy by dx is d square y by dx square. Okay. And this will be dy dx of minus cot theta. Okay. Minus will go outside. Derivative of cot theta with respect to x. Okay. So I'll compare this with cot x formula. Derivative of cot x is minus cos x square x. So derivative of cot theta will be minus cos x square theta into who is x over here? X is theta. D by d theta of x. Okay. This is the chain rule part because we are derivating cot theta with respect to x, not theta. We're differentiating with respect to x, not differentiating with respect to theta. So chain rule will come. Okay. Now we certainly have this value. We just have to look for it. Dx by d theta value we have. So I'll take you back to the previous slide. Dx by d theta is minus a sin theta. I think I have written here something wrong. One second. So d by dx of theta. Okay. X is getting replaced with theta, so theta will be over here, right? Yeah. So I was saying ki d theta by dx value we have, but then we have to refer this dx by d theta over here. So this will be minus a sin theta. So what is d theta by dx? 1 upon minus a sin theta. Is the reciprocal. D square y by dx square is equal to cos x square theta 1 upon minus a sin theta. So d square y by dx square, negative sign goes up, sign goes up, it becomes cos x. So this will be cos x cube theta upon it. A will remain down. Any confusion over here, or have you understood clearly? Yeah, sure. Take your time. So last question of this category, question number 17, sub question 1, question number 18 you can try it at home. Okay, 19, 20, no need to do, but then this much is enough. So question number 17, sub question 1 I'm going to do right now. This is the last problem of higher order derivatives. X is equal to a theta plus sin theta. Y is equal to a 1 minus cos theta. So dy by dx is equal to dy by d theta upon dx by d theta. Equation number 1. X and y are both functions of theta where a is a constant. Okay. So we'll start with y. Y is equal to a 1 minus cos theta. Okay. So differentiate this with respect to theta because theta is the parameter. So dy by d theta is equal to a cos theta derivative is minus sin theta. So 0 minus sine theta, which is equal to a sine theta. Okay, x a theta plus sine theta. Differentiate with respect to theta on both the sides. A will remain a. Differentiation of theta with respect to theta is 1, and differentiation of sine theta is cos theta. Okay, so from 1 we got both the values. Dy by dx is equal to a sine theta, a 1 plus cos theta. Okay, a will get cancelled. Now I'm going to play with half angle over here. Not a requirement, you can also go ahead with quotient rule, but then half angle you get a single term and a less complicated term. So sine theta half angle is 2 sine theta by 2 cos theta by 2. Okay, dy by dx. So 2 sine theta by 2 cos theta by 2 upon 1 plus cos theta. It is 2 cos square theta by 2 half angle formula. So dy by dx, 2 getting cancelled, cos getting cancelled, so this will be tan theta by 2. Okay, sine upon cos is tan. Now differentiate this with respect to x on both the sides, because if you require, we need the second order derivative, d square y by dx square. Okay, so d square y by dx square is equal to d by dx of tan theta by d square y by dx square, derivative of tan theta by 2 sec square theta by 2 d by dx of theta by 2. See, I'm comparing this with tan x, tan x formula. So who is x? X is theta by 2. So d square y by dx square is equal to sec square theta by 2. Half goes out, d by dx of theta. Okay, now focus on this value. D theta by dx. This is d theta by dx. But then what do we have? We have dx by theta. Dx by theta is a1 plus cos theta. So d theta by dx will be 1 upon a1 plus cos theta. Okay, so sec square theta by 2. I'll just write this on the next page. Okay, so d square y by dx square sec square theta by 2 into half 1 upon a1 plus cos theta. Okay, see dx by theta is a1 plus cos theta. So d theta by dx will be the reciprocal of this. Okay, d theta by dx will be the reciprocal of dx by theta. That value I have written over there. Now if you take a look at the problem, they have given theta is 90. They have given theta is 90. Pi by 2 is 90. So put theta is equal to 90 degrees. So d square y by dx square sec square 45 into half. Theta by 2 is 45. 1 plus cos 90. Okay. Now sec 45 is root 2. Sec 45 is root 2 square into half a 1 plus 0. Cos 90 is 0. So if you take a look, root 2 square is 2, 2 will get cancelled. The answer will be 1 upon. The final answer is 1 upon. Are you convinced? So that is the end of this particular exercise. Okay. All the difficult and challenging problems we have done. This was session number 3. Thank you.